Another 1 minute. Write your ID or type your ID on the chat panel. This is official attendance now. Just type your ID. I can tell how many people are really online. I talked about the permission to record. Yes, anybody can record. From your end, do whatever you like with this. Right. Now, everyone now should type last opportunity, last 20 seconds. Type your ID on the chat panel, only once, of course. طيب يا شباب, let me be clear about recording. I will not do anything from my side to facilitate recording. If you find a way to record it, record. From my side, I will not do anything. I'm against recording. Recording means you're not with me. You want to watch it later. Clear? طيب, I talked about permission to record. I said from your end, any way you want to record, it's fine with me. I will not give permission from my end, from my side, because I don't want to facilitate recording. طيب. Okay, now everyone, I assume now it's time over for attendance. So done with attendance now. طيب, let's start. So, Bismillah ar-Rahman ar-Rahim. Last time we talked about chapter 2, and we said it's motion in one dimension. And we said motion in one dimension is a motion along a straight line. This straight line can be horizontal, can be vertical, can be oblique, ma'il, with a slope, doesn't matter. As long as all the motion is along a straight line, this is motion along a straight line. Or in other words, motion in one dimension. Right. Now, last time we talked about the principle of average velocity. And we said in order to understand average velocity, we have to define two things. We have to define position. And we said position or location is a vector quantity. And we said what is a vector quantity? Is a quantity that is specified by magnitude and direction at the same time. So the position is given in terms of a vector quantity in meters, in the unit of length, or meters, or kilometers, if you wish. This position has to be with the direction. For example, if I'm say now, my office is located 5 kilometers from Khobar, this is not position, because I need to say it's 5 kilometers west of Khobar. So the fact that I gave the magnitude and direction made the position correct. After I know the position, we defined another quantity, we call it displacement. So last time we said the quantity called displacement, or delta x, and for sake of clarity, I'll put an arrow here, means it's a vector quantity. It is final position, x final, because the position is a vector quantity, minus initial position. So I'm not interested in the road. I'm not interested in the way to get from initial to final point. I'm only interested in the position of the final point minus final destination minus the position of the initial point where I started my motion. In this regard, we gave the example. We said somebody going from Dammam to Riyadh, he will go west. So if I ask you from Dammam to Riyadh, this trip, what is delta x? You said location of Riyadh relative to the origin minus location of Dammam is the displacement. And in this regard will be negative because I moved west if my origin, if Dammam is the origin. Now, if I go to Riyadh and come back, what is the displacement for the whole trip? 0. The displacement for this trip going to Riyadh and coming back to my home should be 0. Excellent. So in this regard, now you see how physics has certain rules. if I have a value that is displacement and I determine it should be 0, automatically the quantity called average velocity is 0. Because average velocity, V average, with a vector quantity is defined as delta x over delta t, which means if delta x is to be 0, this value, then the V average will be 0. هذا in physics, not real life. Real life تقول what's the سرعة, velocity of something? No, in Arabic, في اللغة العربية, it's no difference between speed and velocity. In physics, we have a quantity called velocity, which is a vector quantity, depends on the displacement, delta x. And we have another quantity called speed. طيب. And then we said, what's another quantity called S average? S average, this quantity is called average speed. So I will write here, average speed. Notice the difference between the word speed and velocity. S average is total distance crossed, just magnitude, just magnitude. It cannot be negative. Total distance divided by total time, اللي هو الدلتا t, of course. طبعا notice that this total distance cannot be negative. It's always positive. For example, I am in Dammam and I want to go to Riyadh. And I need to come back. The whole trip, going back, forward, and back to Riyadh. The delta x is 0. The average velocity is 0. But the displacement, the distance, average speed is totally different. Average speed, this is 400 kilometers. Plus 400 kilometers is 800 kilometers. So 800 divided by maybe 6 hours or 7 hours. This is my average speed for the trip, of course, in meters per second. Did you notice I did not put a vector here on average speed? Yes, it's a scalar quantity. It's not a vector quantity. So average velocity depends on the displacement, and it is a vector quantity. Average speed does not depend on displacement, and it's a scalar quantity. Two different things. Right. So this is what we talked about last time. We said average velocity is defined as V average. Of course, here we need to add a vector, better, okay, in one dimension. By the way, as I said last time, عشان nobody is confused. In one dimension, in a straight line, the direction can be either positive or negative. خلاص, here I have here, this is the one dimension, this is 0, this is positive, this is negative. Because of this, it's not important to put here the arrow. But to be professional, it's better to put the arrow. It's better to put the arrow because later on we'll take 2 dimensions and 3 dimensions. Even average velocity has a unit of length, dimension of it, length over time, or the essential unit is meter per second. So somebody has a question. Okay, go ahead, Hassan Al-Muhammad.
Doctor, what if we have more than 2 speeds and more than 2 time that are given?
Okay, if the 2 speeds over the whole trip, يعني you have one trip, you went from here to Riyadh, then from Riyadh to Mecca.
We have like 3 speeds. 3 speeds and 3 times. What will change in the equation?
It doesn't matter. The same rule applies. The V average is the final destination minus the initial destination. The average speed, then average velocity is final minus initial over delta t. The average speed is total distance crossed divided by total time. Nothing will change. طيب, Hassan, Muhammad, I answered. Hadi Al-Marzouk, go ahead, Hadi.
Yeah, hello, Doctor. Speaking of dimensions, I was solving one of the old exams questions, and I saw temperature. What is the dimension of temperature? Does it have dimension?
No, the temperature, I cannot define it by east and west and north and west and south. Temperature can be positive temperature, negative temperature. It's not a vector quantity. It's a scalar quantity, but it's a special kind of a scalar quantity. Remember, vector means there is direction. انت تقول درجة حرارة 20 مئوية شرق No. So it's not a vector quantity. Right.
I see.
Right. So after we define this quantity, V average, now we see what if we have a figure, and this figure is X distance or position versus time. يعني the y-axis is distance and the x-axis is time. So say that a particle started from this point here. This point means he started at -4 meters. يعني if I to draw it on what you are familiar with, here, this is the origin. So there is a particle here started at -4. Okay, that's the meaning of this figure. And this particle, after 3 seconds, يعني at t equal 4, يعني here at t equal 1, right? So after 3 seconds, t equal 4, he reached this point. What is this point, the x equivalent? 2. So here he reached 2 plus 2. First of all, I know from this that the direction of the displacement is this way. And by the way, I can find delta x, right? I can find delta x. What is delta x? Final, which is plus 2, minus 4. Yeah, 2 minuses. Equals what? Equals plus 6. Now, if I divide by the time, which is 3 seconds, I got what? V average, which is plus 2. Plus 2. So this we extracted from the figure, but also from the figure directly. Excellent. From the figure directly, I can also extract the velocity by the slope, average velocity, كيف? If I take this line from this point to this point, it delta in the location is this value, which is delta y. Until you learn it in math, this is delta y, probably in the previous year or high school. And the delta x is delta t, is the time here, which is the same definition of the V average. So the V average is the slope of this line. I'm talking about the red line. I'm not talking about the green. The green is not, this one is not a straight line. This is just a curve. So notice that it doesn't matter if you go this way or you go this way or you go directly, you still get the same values for the V average. Why? Because you're interested in the final point minus the initial point. So the final point is plus 2 and the initial point is minus 4 divided by the time taken during the trip, which is 4 seconds minus 1 second, 3 seconds. So the result will be 2 meters per second, the average velocity. And it's positive, by the way. Positive means the overall motion happened along a positive x-axis. Yes, because we said average velocity is a vector, a quantity. When we say plus 2 meters per second, we're saying we're giving a value about the magnitude as well as about the direction. Okay? Right. So here we can extract from the figure. As a result, if I have a curve, position versus time, the slope of that curve indicates what? The slope over a period is the average velocity. What happens if I have a curve like this, for example? If I have a curve like this, means what? Means I started here, this is T1, and after some time, I reached here, T2. What is the slope of this curve? On the chat panel, is it positive or negative? The slope is negative, perfect. So it gives me a fact that when I find the slope of this line or this trip, it's a negative slope, means it's a negative velocity, means the particle is moving to the left. وهنا, please, if you can hold a pencil or record it in your phone, my voice now, or anything, record this or write down this. For vector quantities, negative values doesn't mean it's small. It means different direction. For scalar quantities, negative values means it's small. هنا حجاوب سؤال التمبريتشر. Again, هعيدها. For vector quantities like velocity, average velocity, negative values, it doesn't mean that it's small. It's smaller than positive value. يعني minus 10 meter per second doesn't mean it's smaller than plus 10 meter per second. It means only that the direction is different. For scalar quantities, Negative values means it's a small. أعطيك مثال. الانرجي. If I have a particle with certain energy and I have possible energy 0 and I have possible energy here +1 and I have possible energy here -5, and I will tell you this, the energy of the particle that is 0 is greater than the energy of the particle that is -5. يعني لو أنت في particle, physical particle, proton, neutron, electron, that has energy 0, this particle has more energy than the particle that has -5. Why? Because energy is a scalar quantity. And in the scalar quantities, negative means small. 0 is greater than the negative. But if I have two particles, one is a +1 joule energy, the other one is -1 joule energy, then the particle +1 has more energy than the particle -1. Very clear. Now, if I have a particle moving with velocity 1 meter per second, another particle moving with velocity -1 meter per second, both of them, they have the same velocity, only the directions are different. الآن we answer the question of Hassan. It's about the temperature, or the other student, I forgot his name, about the temperature. A temperature of -10 Celsius and a temperature of a +10 Celsius. The +10 Celsius is greater than the -10 Celsius. It's a scalar quantity. تشعر بالبرودة with -10, with a +10 we feel warm, means your body emits radiation, while -10 your body is absorbing radiation, vice versa. Okay, so here is an important note. We will need this note, by the way, until the end of this course, and even in Phys 102, which is victory quantities, negative values. It does not mean it's a small, it's only change in direction. When I said acceleration, التسارع, is a victory quantity, 10 meters per second square or -10 meters per second square, I have the same acceleration. Only the direction is different. Okay. We continue. So we talked about average velocity, and also we talked about average speed. We said average speed is not a vector quantity. It's a scalar quantity. And it only gives me what is the speed of that particle over a period. And we said average speed is total distance over delta t, over total time. So let's take an example. A particle moves, let's take this example. Let me see the chat panel, okay. Do not necessarily mean they are small, but it means they are different direction. Okay, طيب. Now, let's take this example. A particle moves from x equal 3 meters to x equal -3 meters. Let's plot it. Let's plot this. A particle was here at a +3, and then he moved to -3. Okay? The direction, this one is the displacement. It's negative displacement. So if I'm trying to calculate average velocity, I know my average velocity has to be negative. It's not small, but it's negative in direction. So find the average velocity. The average velocity what? -3. -3 -6 divided by 2 seconds, the time of the period, is -3 meters per second. This is average velocity. Now, average speed, when you go from +3 to -3, how many meters you moved? 6. So it is 6 divided by 2, it's 3. So here you see the difference. The average velocity came to be -3. The average speed came totally different thing, is a +3 meters per second. The average velocity is a vector quantity. The average speed is a scalar quantity. The odometer of your car, عداد السيارة, the odometer records a speed. It cannot give you any information. The odometer of your car cannot give you any information about the direction that you are driving in. It only can calculate how many meters or kilometers you cross per hour, and then automatically with a sensor, it can calculate what is your speed. Okay? Right. Now, we talked about, and I always try to connect things to you. We have position, we have displacement, we have average velocity, we have average speed, right? Everybody, it's clear to everyone, right? Again, we have position, we have displacement. Those are vector quantities. From displacement, I can get average velocity, also vector quantity. Then I have average speed, which is a scalar quantity, and it doesn't have direction. So 4 quantities you learned so far. Now I have a fifth quantity I'm going to teach you, okay? It also cannot be negative. A scalar, a distance, average speed, yes, you're correct. But not the scalars can be negative. But in that example, average speed, it's always positive. Yes, correct. Could average speed and average velocity differ in value? I mean, yes, of course they can differ in value. And we brought the example of Riyadh. If I went from here to Riyadh and came back, the average velocity خلاص is zero. Average speed is a value. We gave an example about it. So what is instantaneous velocity? If I have a period and I try to squeeze this period, make it smaller and smaller and smaller, maybe I will calculate velocity at certain moment. That's why it's called instantaneous velocity. An instantaneous velocity is measuring velocity at certain second. And in math, we do this by taking the limit of the same definition of the average velocity, but whenever the period, this delta t, the period goes to zero, it's very clear. If I have a period and I shorten this period of time, as if I take a velocity at certain moment. So in the limit where delta t goes to zero, this you will learn in calculus, in math, okay? So in the limit, and now you see why math is a tool for physics. As a physicist, I should understand math. Mathematician is not supposed to understand physics. Okay. For a student who asked me last time, which is more important? There is nothing called important. Math is important. Physics is important. But as a physicist, you should learn math, good math, excellent math, like a mathematician. As a mathematician, you're not supposed to learn physics. Enough with you with the math. It's an abstract science. Right. So in the limit where delta t goes to zero means I'm shortening this period, means now this is the definition of a derivative in math. In calculus, this is the definition of a derivative. Means if I derive a function that is a polynomial or a sine or a cosine or a tan, and I derive it relative to time, I will get what? At certain time, if I substitute, I get a value called instantaneous velocity. And as the name indicates velocity, it's a vector quantity. So this value can be positive, can be negative, and the negative does not mean it's small. It means it has different direction. So this is a value called instantaneous velocity. Now notice something. The magnitude of instantaneous velocity, هعملها كده اكتبها. Instantaneous velocity is in instantaneous speed. Speed, يعني I will write it like this. Speed instantaneous. Here, عشان ما يصير confusion, هعيدها. Average velocity والaverage speed, they're not related. ما تقدر from average velocity take absolute value or magnitude, you find average speed. Wrong. Instantaneous velocity and instantaneous speed, they are related. If you take an absolute value للinstantaneous velocity, you can get instantaneous speed. عيد. Average velocity and average speed, they're not related. واحدة vector quantity, the other one is a scalar quantity. Instantaneous velocity and instantaneous speed, واحدة vector, the other is a scalar, they are related. If you know instantaneous velocity and you take absolute value, you get instantaneous speed. عيد. No, I will not repeat now. But I will repeat back at the end of the chapter. I know. يعني some of the, that's why يا شباب أنا أقول لكم دائما, students who take my class إذا focus معاي تقطف ثمار. If you're not focused ما تقطف ثمار. You have to be focused. أنا أعمل كل مجهودي, but you have to be focused. طيب. Okay, طيب, clear, ممتاز, good. طيب. So in this regard, now we defined a quantity called instantaneous velocity, and we said we take the derivative, مشتقة بالعربي, high school, prep year, whatever you took. Take the derivative of position, you get the velocity. So this value is called instantaneous velocity. And as the name indicates, لحظيا means I need to substitute at certain time. So the question will come like this. A particle moving with a certain position function, x of t equals blah, blah, blah. Find the instantaneous velocity at t equal 3. So I need to derive and substitute at t equal 3. And that's how the question comes. لكن instantaneous speed, we said, is related to instantaneous velocity. How is related? It's the magnitude or the absolute value of instantaneous velocity. Let's take an example about this idea. A velocity of 5 meters per second and minus 5 meters per second. So you have two velocities. هذه ال 5 meters per second means the particle moving to the right. This means the particle moving to the left. Two velocities. Both of them, the absolute value is what? Is 5. So both of them, they have the same instantaneous speed. طبعا if the word instantaneous disappears means it is instantaneous. Otherwise, the average, we say average. لكن لو أقول speed, what's your speed? Means I'm asking about your speed now. If I said, what's your velocity? But if I said, what's your average speed? What's your average velocity? Something different. Okay? Let's take this checkpoint. If following equations give the position of a particle in 4 situations. In each equation, x in meters and t in seconds. So I have particle moving in 4 different equations, 4 different position equations. The first position equation, 3t minus 2. The second one, minus 4t squared minus 2. The third position equation, 2 over t squared. The fourth one, x equal minus 2. It does not depend on time. يعني هذا البارتيكل is always moving with x equal minus 2. خلاص. It doesn't change with time. هذا the last one, the position is fixed. He cannot move. With time, he's in the same position. فهمتش معناها؟ طيب. In which situation is the velocity of the particle constant? Simple. I derive and I see the derivative, the velocity. If the velocity does not have t dependence, means it's constant. Take the derivative of the first one. What is the derivative of dx by dt, this function, the first one? احنا قلنا for the polynomial, I refer you to the first lecture. Drop الباور اللي هي ال1 here, drop it here, so it's a 3 multiplied by 1. T reduce الباور by minus 1, so it is 0. T to power 0 is 1. So it's a 3. A derivative of a constant we said is 0. So the answer is a 3. Now, هذا derivative, clearly it's a constant. The velocity is a constant. Situation 2. Let's take situation 2. يلا derive 2. Situation 2. Situation 2, dx by dt. MashaAllah, let me see. Oh, excellent, excellent. MashaAllah. And I have excellent badge. MashaAllah, this is good. ما تخيلوا الفصل الأول غلبوني. No, MashaAllah, this is excellent. Excellent. Now, if I derive this, it's minus 8t. Minus 8t. Oh, this is good. Means you have t in the function. Yeah, so this is velocity, right? But you have t, which means this is not constant. Oh, this is not constant. It has a t dependence. By the way, this one also, when you derive, you also will have t dependence. So it is not constant. The fourth one, derive, you get 0. 0 is a constant. So situation 1 and 4, they have constant velocity. Constant either 0 or a number without a t dependence. Part P, in which is v is negative direction. In negative direction, the one that gives me negative values. Number 2 give me minus 8t. So if I substitute any t, time can be 0 or above. If you substitute any value higher than 0, it's always negative. So situation 2 has negative velocity. How about situation 3? Yes, هذا الfunction is negative. When you substitute t, any value greater than 0 to infinity, you get it to be negative. So 2 and 3 are the negative values. Yes, perfect. 2 and 3 are the functions that, the position functions that will give me negative velocities, negative direction. طبعا negative direction velocity, I'm talking about direction. I'm not talking about how big or how small it is. It's important. Type. So we learned about instantaneous. What do you think instantaneous velocity and speed are represented on a curve? I cannot take period. I need to take it at certain moment. For example, if I have here this function, and this function position versus time for a particle, and the particle moves along this curve from 0, then A, then to B, then to C, then to D, this blue line, right? Now, the particle from 0 time to time equal 1, what happened to it? The position is 0, means the particle did not move. So I expect the velocity function, which is this region here, should be 0. Yeah, velocity 0. But from another way, if I take the slope, tangent, take the tangent here, هذا tangent. Take the slope of this tangent is 0. وقلنا the slope of position is velocity. So here 2 ways. طيب. What happens to the particle between point A to point B? Between point A to point B, the particle position started to increase with time. شايف ال x-axis is time. The y-axis the position. The position at 1.5 is here. The position at 2 is here, is getting greater. The position at 3 is greater, is 5. So what happens? The position is increasing in the positive direction with time. So between point 1 and B, I have increase in the velocity. The slope of this line is increasing. So I have velocity that is increasing. How I know velocity at every moment? Let me just clarify this. How to find the velocity at every moment? I need to take a tangent at each value. I take a tangent here, tangent here, tangent here. A tangent, and I wish I draw it in a better way. Let me just take this line here. شوف هذا tangent, then the tangent, then this one tangent. If you notice, a tangent of the line is getting bigger. The slope is getting bigger. That's why the velocity from A to B, from 1 to B specifically, is increasing. طب what happens from B to C? هذا السؤال مهم. From B to C is a straight line in the position. And what is the slope of a straight line in math? The slope of a straight line is a constant value. صح? Let's see. Chat panel. يا سلام. Excellent. A slope of a straight line in math is a constant. This is how you define a straight line. إذا عندي position is a straight line, and I take a slope of this period between B to C, it's the slope of a straight line, which is delta y over delta x, which is constant. And constant means it is this region. هذا الريجن اللي حرسمها هنا. لاحظ هذا constant. إذا between B and C اللي هي هذه الريجن, what happened? The velocity is this. It is constant. Again, why? Because in math, we know the slope of a straight line is a constant. And a constant means when I draw it on the figure of velocity versus time, I need to draw a constant. How do I draw a constant? It's a horizontal line. It doesn't change with time. طيب. Between C and D, this is C and this is D. What happens? هذا tangent, then a tangent is decreasing, a tangent is decreasing. So what happens between C and D, that the slope is decreasing. So the velocity is decreasing. It's opposite to the effect from 1 to B. But what happens when he reach point D, this one here, this region here, its slope is 0. So it goes back to 0 here. The velocity is 0. So here we did analysis for a motion. We gave the two, we can have the figure of the position and we can get the figure of the velocity out of it. We can get the figure of the velocity out of it. Let me see if anybody has a question. Okay, let me see on the chat panel. Because the direction, directive down, concaving down, decreasing, yes. I joined at the time and I wrote my ID number, then I had a problem in Zoom, so I left, then I had joined again, so do I need to write my ID? طيب, this is, last time I will allow this, now you can type your ID. But next time, this is not allowed. When I say attendance taken now, attendance taken now. Means you left the room. Okay? طيب. طيب, good. طيب, whoever also, this is one time allowed, whoever joined late, now he can type his ID, but next time it's not allowed. Because I have the record of the chat panel. I can download it, I have the record, so I know at every moment, when did you join and when did you not join. Okay, so next time I will not allow this. Can you explain again, Doctor? So as I said, I have here position function versus t. I can extract what happened to the particle in all these 4 or 5 regions, here, here, and here. Those are 5 regions. This region, nothing happened. The slope is 0, so the velocity is 0. Between this one and B, the particle is increasing his position with time, so the velocity is increasing. Between B and C, this region, what happened? The slope of a straight line is constant, so it is constant. Between C and to the neck of this D here, up to here, the particle is decreasing his velocity. And when he reaches this is constant status, the slope is 0, so the particle velocity is 0. Okay? طيب. A function is a constant whenever I have a function that does not have a t variable or x variable, means it's constant. If it doesn't have t variable, means it's constant with time. If it doesn't have x variable, means it's constant spatially with position. I hope it's clear. If it doesn't have variable t or variable x, means he is constant in time and position. Now, after we define, so far, yalla, position, vector, displacement, delta x, vector, quantity, average velocity, delta x over delta t, vector quantity, average speed, total distance over total time, اللي هي scalar quantity. Then we define instantaneous velocity by taking the derivative and substitute at that time, هذه vector quantity. We said if we take the absolute value of instantaneous velocity, I can get instantaneous speed. Now we define another quantity. Acceleration. And acceleration has also similar to the velocity, has different categories. Here I have V average, A average means V final minus V initial over delta T, يعني delta V over delta T. And this is a vector, a quantity. And again, vector quantity and negative means different direction, but it's not small. طيب. Similarly, if I take a derivative lel velocity, I get what? Instantaneous acceleration, صح? Similar to the velocity idea. So if I have position, take the derivative, I get velocity. Velocity, take a derivative, you get acceleration. Instantaneous acceleration. Instantaneous acceleration. By the way, acceleration is acceleration. I don't have equivalent to the speed to acceleration. So dv by dt at certain time, it's called instantaneous acceleration. Type. Good. So either I say acceleration dv by dt or the second derivative of the position. هو ايش العلاقة بين هذه وهذه وهذه? Those three. What's the difference? What's the relation between them? Either acceleration is the first derivative, instantaneous طبعا, first derivative of the velocity, or it's the second derivative of position. يعني أجيب البوزيشن, derive first time, I get velocity. Derive a second time, I get الاكسلريشن. اعطيك مثال x of t حلنا. تذكر هذا اللي ايش كان المثال؟ كان المثال minus 2 t square. Yeah, minus 2 t square minus 5. هذا position. Now to get the instantaneous velocity, derive. If I derive, what you get? Minus 4 t, right? لانه يدروب بالباور, reduce 1, minus 0. هل هذه velocity constant or variable? It is variable with time. It changes with time because I have time dependence. Okay, perfect. All the guys in the chat panel, excellent. So it's variable. Now, find the instantaneous acceleration. You derive again. When you derive again, what you get? Minus 4. But let me ask you, is this constant acceleration or variable acceleration? الإجابة على الchat panel. Is this constant or variable? Of course, it's a constant. And it's a negative constant. Negative constant, it doesn't mean it's small because the acceleration is a vector quantity. It means in the opposite direction. Okay? So here is, if I took a second derivative of the velocity, I get an acceleration. I think it's clear. طيب. So what do you think should be the unit of acceleration? طب الاكسلريشن how it's defined. يلا extracted. الفيلوسيتي هذه معناه what؟ السكند يعني هذه meter per second divided by second, another second. So it's meter per second square. This should be the unit of the acceleration. Why? Because I'm dividing velocity by another time. But what's important and I want to focus on regarding acceleration, acceleration هو variation of velocity with time. يعني particle that is moving. يعني شوف you're going to الكورنيش in certain direction, in one direction, straight Bibsi Road, okay? It's a straight line, okay? From here along the Bibsi Road, okay? Straight line. And you fix with the cruise control, you fix your car speed. The acceleration, I assume, to the Corniche is 0. While acceleration is 0, you did not change your direction and you did not change your magnitude of your speed, which means there is no variation of velocity with time. نرجع هنا لتعريف acceleration. والاكسلريشن يقول variation of velocity with time, delta v over delta t. But if there is no delta v, means I don't have average acceleration or even instantaneous acceleration. إذن acceleration is best described in physics as the acceleration as the time variation of velocity with time, or the time rate change of velocity, or how the velocity changes with time. If the velocity of a particle does not change with time, means the acceleration is 0. طبعا the variation of the velocity not only magnitude, also direction. يعني كيف أنا أشرح لك. لو أنت moving like this 5 meters per second and suddenly you switch also 5 meters per second, someone will say, yeah, كنت تمشي 5 بعدين ضليتك 5. No, في acceleration هنا. Why? لأنه here it is +5, but here it is -5 meters per second, the velocity. So the overall acceleration will be what? -5 minus +5, so it's -10. So there is acceleration. So either you change the magnitude of the velocity, or you change the direction, or you change both, you get acceleration. If the magnitude doesn't change and the direction doesn't change, I don't have acceleration. It's very important. Fine. So here, similarly, remember this figure? This is for the same example where we extracted the velocity from position. Now, we try to extract the acceleration from the velocity. كيف؟ نيجي هنا. Between 0 to 1, what is the velocity here? هذا the velocity curve. Slope, the acceleration. So the acceleration is 0. Yeah, because the slope is 0. Between 1 until B, what happened to the velocity? Is it increasing? It's a straight line. It's increasing as a straight line. And what is the slope of a straight line? Is constant. يا سلام. شوف. الأكسلريشن هنا constant على هذه القطعة. Why? Because the slope of a straight line, let me see the chat panel. Excellent. Why? Because the slope is of this velocity is the acceleration, and the slope here of a straight line, and the slope of a straight line should be constant. ناخذ الريجن هذه نركز لي عليها. B to C. ركز. هذه velocity is constant. The slope of this should be 0. That's why between B and C, what is the acceleration? 0. إذن acceleration between B and C مش constant. It's constant, but it's also 0. Why? Because between B and C, I have no variation of acceleration. So it is 0. It's a straight line. The slope, it's a horizontal line. The slope of a horizontal line is equal to 0. Excellent. Acceleration when speed is constant. Yes. Type. Excellent. Now, between C and D, what is this? Between C and 9, هذه up to here, this region, what happened? Slope هذا is the acceleration. Is it negative or positive? It's negative. شوف هنا. The 9 is negative. طب afterwards, when he reach here, what is the slope? Is 0. So back to 0. It's beautiful. It's a game. You should enjoy it. You should enjoy it. That's why I became a physicist. I can enjoy science. It's not boring. It's beautiful. It is 0. Why? Because the slope of this is not changing. The slope is 0. So the acceleration has to be 0. Let's take this beautiful example. Okay, let's take this beautiful example. Let me just pull this here. طيب. طيب. هنا, you drive a beat up pickup truck along a straight line road for 8.4 kilometers. Okay, أنت بتمشي بpickup truck 8.4 kilometers at 70 kilometers per hour. So means a distance you move from here with 70 kilometers per hour 8.4. Okay, good. هذا أعطاك speed. He gave you the speed along this period, which is 8.4 kilometers per 70 kilometers per hour. and he gave you the distance you crossed, 70 kilometers per hour. At which point the truck runs out of gasoline. Hina, you're out of gasoline. So there is a gas station here, so you move to this gas station. Over the next 30 minutes, you walk another 2 kilometers. So you started here and you ended up here. Not 8.4 kilometers. How many kilometers overall? 10.4, because you moved driving 8.4, then another 2 kilometers walking. So from final to initial, so delta x at displacement is 10.4. Why? It is the final position minus L0 initial position. So it's 10.4. What is the time interval from the beginning to your drive to the arrival at the station? Tell me time of all this period, the time consumed. From here to here, I can find the time by dividing in velocity over distance. I can get the time, or distance over velocity. So if you do it, you get the time to be 0.12 hours, fraction of an hour. Then it took you 30 minutes to walk to the gas station. So if you add the 2 times, you get it time from the beginning to the end. Simple. How to get it time? If I have a distance, I divide by the velocity, I get it time. So here I have a distance, 8.4, and I have a velocity. Divide, you get it time. Add to this 30 minutes walking, so the time from the beginning of your trip to the gas station is 0.62. 0.62. Yeah, 30 minutes, but you should add to it a time while driving. You should add to it the time while it is driving, okay? طيب. الآن part C, let me just erase this. You see part C. Part C, he said, what is your average velocity from the beginning to the arrival at the station? Well, average velocity is very simple. Delta x over delta t. Delta x is the displacement, which is what? 10.4. That's my total displacement, divided by total time, 0.62. So it comes out to be my average velocity is 16.8, and it's positive, means it's to the right. It's a vector quantity. Part D. Suppose that to pump the gasoline, pay for it. انت هتحمل tank من الجازولين ترجع للسيارة. Suppose that to pump the gasoline, pay for it, and walk back to the truck takes you another 45 minutes. So first 0.12 of the minute of the hour, then 30 minutes, then you filled a tank in your hand and you went back to the car another 45. What is your average speed? The average speed is not average velocity. It's total distance. What is the total distance from the beginning of the trip to here? Come, 8.4. Then 2 kilometers. Then I need to get back another 2 kilometers to the car. Here is the car. اجمعهم بيطلعوا 12.4 kilometers. هذه total distance crossed. Divided by total time consumed. هذا التايم زائد هذا التايم زائد ال 45 minutes. Add it all 1 hour and 37 minutes of the hour. Divide 9.1. So the average speed is different from average velocity. Yes, and add to the time 45 minutes. طيب, anybody has a question? Anybody has a question? Let me see. Chat. About the speedometer, does it show your real speed with the friction or the speed that the car is produced by the engine with no friction involved? No, it doesn't take care of the, it just calculates the rotation of the wheel, assuming that the friction is so tiny. It just take the rotation of the wheel. It calculates how many rotations of the wheel, so it can find the linear speed, okay? طيب. In the previous step, when we find the time, we find the time for the whole trip from the beginning to the where the car ran out of business, out of gasoline, then to the gasoline station, then back walking to the gasoline. 3 periods of time, 0.12, half an hour, and 0.45 of the hour. Add them all. I need all the time. هذا example is good. It just needs studying from your side. You need to study it carefully on a cup of coffee. And I told you the recipe. تبغى A+, سهلة. في هذا الكورس, study كل lecture in the same day it's delivered. You get A+. I guarantee. Okay? طيب, any more questions? طيب يا شباب, we're out of time. We need to stop. I like to all the time to finish on time. Okay? So, no, I mean, could you go back? Can you repeat how did we get the time from A? Well, the time from A, you divide a distance by the velocity of this period. لانه v ايش equal لل v distance over time, right? So time distance over velocity. Time is distance over velocity. طيب, we continue إن شاء الله next time. If you still have any questions, send me by email. إن شاء الله I will reply. طيب. Oops.